Hi, my name is Enme435 and this is my test scan for homework 3 of my target. So as you can see, I have my scanner set up on a tripod. Like I mentioned in my last video where I forgot to lock the horizontal movement, I now have the horizontal movement locked so it can only move up and down. I have my laser going, the Pi being powered by, or both being powered by the power bank. And then on my laptop, I have the virtual desktop running with the program and the process I've been going with. So right now, I've been taking the angle by placing my phone at the top horizontal edge or top edge here so I can get the angle. I enter it into the program and then it takes the picture. So I've run the program. It prompts me to enter the angle. Right now it's at 300 degrees. I enter 300-degree angle. It will now take the image. You could see the laser there on Testudo's legs. When it is done, the image is now loaded into my Testudo images folder, which I will then upload onto my laptop when I'm done. The only potential issue I've identified with this target is that the back is not easily accessible due to the wall, and then also the left side could be a little tricky to scan also due to the wall getting in the way. However, I will try to work around this. Thank you. With my target being Testudo, obviously the key features are the legs, the torso, his arms, and then also the head, as well as other details such as the shell and the arms. So there are plenty of creases and features for the LiDAR sensor to try and detect. Now that the target images were acquired, the next step is to transfer the folder of images onto my laptop and then run it through the data generation program. The first step was I selected a random image, actually a few of them from the folder, and I ran them through the color picker program to determine the best threshold values. I decided to just use the same ones I used for my initial target scan as well. And so here's an example image and another one where you can clearly see the red laser on the Testudo statue. And essentially running it through the program, these are the threshold values I settled on. I added in my tuned, or I should say, calibrated values for the distance, and then it reads the individual images from the folder, and then also adds the results into the same folder so that I can open it in Cloud Compare. And the results is a text file that's generated by this script. And the only change I had to make to it really was regarding the angle calculations, because initially it seemed as though it was taking my vertical angle values, or in other words, the titles of each of the images, and applying it not only to each individual row, but also constricting and altering the other X, Y, and Z axis as well. So I added this new bit of code as well as this, which tweaked it and allowed it to work. And then with the text file, which is here, I loaded it into Cloud Compare. With Cloud Compare open, following the same procedure, I go into my Testudo images and I load in the text file. So this is what the original scan data looks like. You can see there's a decent amount of noise in the background. Most of this, I believe, is caused by the bushes that were behind Testudo picking up the laser. And then here we have the ground. These lines here, I believe, are also distortions from the ground. But overall, you could clearly make out the Testudo shape right here. And so after a little bit of trimming, I ended up with this. So this is the fully cleaned up Testudo image with the height ramp applied to it. And as you can see, you can clearly make out the two arms, the legs, the ground where he's standing. You can even make out the book that he holds in his hand. And obviously this side is missing a lot because the laser was only looking really at this front side. But overall, I'm very pleased with how this initial scan turned out. And yeah, once I get the other side scanned, I should have a fully 3D model of Testudo. And now in order to actually scan these, I moved 1 degree up at a time. However, somehow I went back and I'm missing 66 degrees, my image at 66 degrees right here, which is the reason for the loss of the line right there. Either I skipped the point or somehow it got deleted, but I'll figure that out. And overall, I'm very happy with the result.